Hi guys, Dr. Orlando here with a video on the scientific method. This is just going to be a quick overview of it, how scientists use this method to do good scientific studies. And this can be applied to all of the sciences, from psychology to biology to physics, engineering. All of the sciences will and do use the scientific method. It is tried and true, it is repeatable, and reliable. Okay, so the way the scientific method works is there are some key steps to it, and usually it starts with an observation. Before you even start the scientific method or a researcher starts it, they notice something is happening in their world. Okay? They make an observation, and that observation leads to a question. Why is that happening? Okay? And then from there, they want to answer the question, because that's what we want to do in science, right? Is answer all of those questions. So the answer to the question, the supposed answer to the question, a possible answer to the question, I'll get it right, is the hypothesis. Okay, so they'll make a hypothesis, what they believe is the answer to their question. Then they'll make a prediction, which is an if-then statement. If we do this, then this will happen. And that will lead to them developing their experiment, the procedure for their experiment. And under the experiment, we're going to go through each of these with an example. In the experiment, there will be specific groups. There will be variables that we can control, things we measure. There will possibly be placebos. So we're going to talk about a lot under the formation of an experiment and the design of an experiment. And then from that, they're going to collect data during the experiment and analyze that data and then draw a conclusion and ask the question, was our hypothesis supported? What happened, was it what we expected? Okay. And then if it's all really good science, if we believe that what we've done is right and we've done a good job following the scientific method, then we may want to submit that for our peers to look at. And one way you can do that, of course, is to submit your research to a scientific journal where your peers will read it and decide whether you did a good job. And if you did a good job, you might be published in that journal, and then everybody gets to read it. Okay, so what we're going to do now is we're going to take these steps and we're going to do a quick example. Okay, so here's a made-up story. This is not based on any data that I've looked at, just kind of making something up. And we're going to say that we made an observation. And that observation, here's a little eyeball, noticing that we're looking at this group of people. We'll say it's a village somewhere, and they drink green tea almost exclusively as their drink throughout the day. And we notice that they're all relatively thin. There is nobody in the village who is overweight or obese. And you kind of look at them and you think, I wonder if it has anything to do with the green tea. So that's our observation. Okay, so from there we pose a question from our observation. If we gave people green tea extract pills, would they lose weight? Okay, so we have to, from there, then go on and make our hypothesis. Okay, so our hypothesis is a statement. Remember, it is a statement that answers the question. Okay, answers the question. And it's not necessarily true. It is a supposed answer. So it's a possible, plausible. It's possible. It's plausible. And most importantly, it is testable. So we make a prediction. If we give a group of overweight people green tea extract, then they will lose weight. Some key words here in prediction. If then. If we do this, then this will happen. So you're going to say, the if statement tells you what you're going to do in your experiment. The then statement supports the hypothesis. Okay? So it helps you design the experiment and get you thinking about how you're going to set the experiment up. Okay, so let's look at the experiment. All right, so now we're going to design our experiment. Some things that we have to decide is who is going to be our test subjects. And we'd like to try to get our test subjects to be as similar as possible. If this was a mouse study, we might even buy clones so that they are all genetically identical. Okay, but we're doing a human study here, so we're gonna set some parameters for our participants in this study. So we're gonna say that these people have to be 30 to 40 years old. Let's have them be women. Let's have them have to lose or need. We could say how much they have to lose, or you could use the BMI scale. You'd have to have some way of putting them in a group together. Let's say that they need to lose at least 20 pounds. Okay. All right, let's say that they can't have any other health problems. And you'd probably have a lot of things that they couldn't have besides, they couldn't have had bariatric surgery, they couldn't have had any kind of digestive issues or other health issues. We don't want them to be on any other medications. Okay, what you can see that I'm doing here is that I'm putting on some controls on this, some controlled variables or standardized variables. Okay, so we call these controlled variables. Sounds like an oxymoron, right? Well, these are variable. People can be different ages. You can have different sexes. We could even put in race here if we wanted to do that. We could say that they, could have any size, weight, but we're going to control it. We're going to try to limit the different variations among our test subjects. So those are controlled variables. So once we have these people, we have to split them into two groups. Okay, we're going to have what's called the control group, and we have the variable or experimental group. Okay, so in the control group, we're going to give these guys, the control group is the group that gets no treatment. In this case, the treatment is the green tea extract. So we're going to give them a placebo. And the placebo is designed. A placebo is a sugar pill, basically. It's a pill that looks just like the other pill. It's the same size, the same weight, probably the same color. It's exactly the same, but it doesn't have any drug in it. Just has some sugar in it or something that would not affect them in any way. Okay, so they're going to get the placebo. Do they know they're going to get the placebo? No, we are not going to tell these groups. We're not going to tell the women in either group what they're getting. So we call this a blind study. Okay, because they don't know what they're getting. The experimental group or the variable group is going to get the variable in the experiment, and the variable is green tea extract pill. Okay, and we'll say what they're going to get. They're going to get one pill one time a day. Same thing here. We are going to control some more things here. We're going to tell them that they have to take the pill in the morning on an empty stomach. Okay, you're going to control everything you can. You're going to tell them to go about their daily routine. Do not add new exercise programs or anything you want to just keep everything as they lived their life previously, just adding the green tea. Okay, so those are the things that we will be asking these people to do. Now, some other terms that we need to define in here. As I said, this is the experimental or variable group. Sometimes this is referred to as the independent variable. Whatever you're testing, for example, the dosage here is considered the independent variable. The dependent variable, let's move this up. So the independent variable is what you are testing. So in this case, it's the green tea extract pill. Okay. Okay. The dependent variable is what you are measuring. And probably while I'm writing that out, you're thinking, okay, I know what you're measuring. You're measuring weight loss. Okay, you're measuring weight loss. So the dependent variable is dependent on the independent variable, right? What we're testing. So it's dependent on the dosage of green tea. Okay. All right. So we did the control group, the variable group, dependent, independent variable, our controlled variables, all those things we like to keep under control to make both our control group and our experimental group the same. Okay. So from there, we're going to start collecting data. We're going to tell these women how long they need to take the pill, and we're going to measure weight loss at a period of time. If we also, and probably not as significant in this kind of study, if we have kind of this hierarchy, if you have a researcher, okay, so that's you in this case, right? And you're going to have some nurses or doctors working for you, okay, and they're going to look at the test subjects. Okay, and I just said that the test subjects, they don't know what pill they're getting, right? So it's blind. If we also don't tell our nurses or our doctors what they're getting, and in this case, weight loss is kind of hard and fast. You step on the scale and it shows it, but other times what the nurses or doctors have to assess is a little more subjective. Improvement in motor skills or improvement in Parkinson's symptoms or something like that that's a little more subjective. You might also want to not tell the nurses and doctors if the patient is getting the treatment. Okay? That way they aren't biased. They don't look at the person and think, oh, they are better, when maybe they're really not, right? So if both your test subjects and your people that are analyzing the test subjects are blind, they don't know whether or not the subject is on medication, we say that it's a double-blind study. And I think that that's a great way to go because it really eliminates something that can really hurt research, and that is bias. Okay. For example, we all, you want something to work, and maybe just because you take that placebo pill, you, not really on purpose, but you're just a little more conscious of what you're eating, a little more conscious of the fact that you should walk upstairs instead of taking the elevator. So it might, just the fact that you're taking any pill could change that. So we like to blind the study so that the people don't know what they're getting. All right, so we collect some data, and I'll just make some stuff up here. Let's say that the control group, they lost let's say they lost an average of 2 pounds, okay, over 1 month. Okay, the experimental group, the variable group, they lost an average of 10 pounds over 1 month. 1 month. 1 month. Okay. All right. So, you see some significant differences here. You would analyze this data statistically, and there are programs and math that you can compute to tell you whether or not it's statistically significant, whether it's a real and reliable data that you have collected. Okay, and then from there you'd make a conclusion. And if this were, let's say that our data came back, it was analyzed, that it was significant, we would say the conclusion is that our hypothesis was supported. Okay, our hypothesis was supported, and that green tea extract caused significant weight loss. Okay, so from there you go ahead and write up the whole paper, send it off to the Journal of Nutrition or Journal of American Medical Association, and hope that your peers like it and believe that your research is good, and you've created good groups, and you've got lots of test subjects in each group, and you publish it, and there you are. Okay, all right. So that's the scientific method. If you have any questions about that, please feel free to contact me. Have a good day.